Okay, here we go. Chapter 5 test review. So, did you try doing one like the first problem?
Oh, yes, we did. I actually got through.
Absolutely.
And do you have any questions about it?
I just want to go through those struggle ones.
What?
Yeah, make
The
sure.
struggle ones?
It's a struggle.
The struggle ones. So,
Yeah.
So, my question is, does anybody want to go over one number one?
Hold up, let me look at number one.
yeah.
This is what it says.
We
It
didn't
says,
have enough time.
listen, it says consider the region enclosed between the graph of, and it gives you a polynomial combined with a transcendental function. So it's got a mixed thing.
Wait, number one on this one or?
This we'll go through this one.
This sounds later.
Yeah.
Right. Yeah.
Right.
My organizational skills are on page 270.
Okay, so the function that you are given involves a polynomial and a transcendental in the same function. You know what transcendentals are? There's
They.
functions, logs, and exponents. Okay? And the x, okay, so it says consider the region enclosed between the graph of this weird function and the x-axis between 1 and 5. It says for x between 1 and 5. Find, and it will either say L, M, or R RAM sub, I'll even tell you. It says sub 4. What does that mean?
4 ends. 4 partitions.
4 intervals. So it'll say LRAM in all caps and have a little subscript 4. That means 4 intervals. Okay? Find L, R, or M RAMs of 4. The area estimate obtained using 4 midpoint rectangles. It actually says that.
Can we use?
Raymond, sure.
So you just put in the function and
Yeah.
bound it.
I thought we had to
If
do it
you're
by
sure
hand.
you want to trust your calculator.
Does it, I'm trusting the calculator.
Okay, that's great.
Does it want area or the integral? I feel like she's trying to.
I think those are the same thing.
They want you to approximate the area.
Okay. They're similar, but if you do the integral, it's gonna minus anything that's on your x-axis.
So you'd have to graph it first, take a look at it from the interval, and then find the intervals.
Or absolute value and put the function in. Okay?
I don't know if I trust myself to do that.
Okay, here we go. How about number 2? Was that one of the ones I gave you to practice?
Oh, yes.
Having trouble with those, are you? Did you want to know the answers? By the way, the key was in my book yesterday.
It was, oh, but you didn't put the book out.
Miss J, we
I
are.
know, I said I forgot to tell them.
We are supposed to use Remon on this, right?
On the first one, yes.
Yeah. Wait, why not on the second one?
Probably you are there too, except for in a different way because now I think you're finding
Volume.
volume.
Oh, the first one's not
Do you have the answer
You
sheet?
can use Riemann to do number 2 too, but you have to adjust it a little bit.
Yeah, that's what I was.
Wait, how do you have to adjust this?
So you have to turn this into radius.
Well, I got that.
Yeah.
Oh,
So let's try my square.
Did any of you try the first one for number 2?
Yes.
What'd you get?
I did not
I did not write it down.
709.91.
That's
what they got here, because they helped me with it. Yeah, so that's what that's all, yeah, I just did.
So my question is, are you okay with it, with doing that?
Yeah.
Can you go over it?
Yes. Let's do it. Let's just do it because.
Oh, I got it.
So a solid is formed by revolving the curve, and it's an ugly curve, but it's not transcendental, it's just kind of ugly.
Beautiful face though.
By revolving this curve, which is 4x to the 3/5 plus 2, and then add 3, on the interval from -1 to 3, that's why I drew the picture the way I did. By the way, there's a picture provided for you on the test. It's better than my picture. And it says, estimate the volume of the solid by partitioning the interval from -1 to 3 into 6 subintervals of equal length. Slicing the solid with planes perpendicular to the x-axis, that's what those lines are, those vertical lines. Right endpoint, using right endpoints and constructing cylinders of height 2/3 based on the cross sections at these points as shown.
I love
Okay,
that.
so I read it. So, do you have any idea how to tackle this?
Yes.
How do you tackle it?
You make your lines, which make a bunch of cylinders. So you've got 6 cylinders.
Okay,
Now you need to add up the volume of all those cylinders.
okay,
So you do the formula for area of a cylinder, which is pi r squared.
that's a good place to start. So a cylinder, one of these cylinders that you pull out like a record and lay it down, looks like this, short. cylinder like that. I know it's up in the drawing, but. And the volume of a cylinder is what?
Higher square.
Pi r squared h. So volume is pi, what's the radius of this cylinder?
R function
The function,
F of X.
from the x-axis to the y-axis.
Square.
squared.
Square.
And how tall are these?
2/3. But
How do we know it's 2/3?
it says
Oh, it says, and if it didn't say.
5 by 6. So that-
Yeah, they wanted 6 sub-intervals, and so it goes from -1 to 3, and -1 to 3 is 4 units, divided by 6 divisions, makes each one 2/3 thick. You see what I'm saying? Okay, so this is 2/3 right here, but when you go to use your, let's say we did, what RAM did I tell you? Did you find that in
It
there?
says R.
It says right endpoints, you have to pay attention to that. So we're gonna use RAM sub 6.
Yes.
That's what that's way of writing it. How are you gonna do it on this one?
I'm gonna plug that into y equals,
All of it,
except for the 2/3.
except for the 2/3,
Because-
remember? To do volumes with RAM, you have to let the 2/3 occur because of the number of intervals you're doing. Remember, it'll happen when it says how many intervals, as soon as it says that, and give me a start point and an end point and how many intervals, it will make the 2/3 for you in the calculation. So what are you going to put specific to this? What are you gonna put in your RAM? Pi times
4x. Plus 2.
to the
3/5.
3/5
Plus 2.
plus 2
Plus 3.
plus 3
Sam,
squared, right?
Square. Yes.
The whole thing squared. And then that's what you put in for f of x. When it asks you what's f of x. And then when you give it the start and end point and the number of intervals, it will build the 2/3 in, but you don't do that, not when you're doing volume. Or, and you may wish to do this in a testing situation, or the volume of each cylinder separately. That can be kind of rough. And add them up and see if it matches what your RM may be. If you're willing to trust your calculator and that you put everything in correctly, that's great. But remember, if all you give me is an answer, it's all or nothing. Either get it all right or get it all wrong. And this is a pretty complex little problem to do by hand. So it's worth some points. Just saying, be careful. Let's see if you can all arrive at 709.91. See if you have see if your calculator skills are sufficient to the task.
Yeah, it's had it in my life.
Okay, all right.
Yeah, same, bro.
I went back in this whole
Program.
Can I help anyone put it in the calculator? Or if you're not getting the answer, can I help you troubleshoot it? Are you getting it okay?
We are doing it right, right?
program.
Right.
Six. Where is
Now, it may say something different on your test. Pay close attention to what it says.
Jacob fought me on that yesterday.
Well, I wasn't.
He was saying you didn't use any RAM, but I said, well, let's create it from the right endpoint.
Yes. Pay attention to what it says. It's just
It's
not-
constantly.
709.91.
Yeah, we have too many closing parentheses.
709.910.
You want to just mix this up since you haven't done all that? Let's just do that. This is one of my rough kids next time.
Why does my screen always get moved back? I keep switching it.
I don't know, throughout the day, different people form different groups and stuff, I don't know why that happens, but you're welcome to change anytime you want.
I'm gonna open it, put it in the background.
Okay. Anybody not get 709.91? Anybody not able to get that? You all understand the process? You've got to put this in f of x, not this. That's the clincher. So if you want to write down the answer to number 2 and then see if you can get it, I'm not going to give you time to do it, but at least you'll have the right answer. The right answer to number 2 is, are you ready? It's 195.284.
Wait,
The second one, the second number 2 should be 195.284. So that's one for you to practice and see if you can get the right answer. Okay? You ready to go on? You wanna take a look at it? Yeah.
Can you explain again why we don't multiply a 5 and 2 series?
There we go.
Because you're talking 3 dimensions here, and the R round, L round, and A round. Is that one thickness, because you're taking some up, plot it down, and that 2/3 is built in when you say, I'm going from -1 to 3.
We have one less student.
That's already on that.
It explodes.
So the function does not include the width. So width is built in when you tell it how many punches. Okay, so you want to take a look at number 3? Are we okay on number 2, everybody? Okay. Number 3, did you try that one?
Yes.
Yes.
By the way, the answer is 8a squared plus 4a.
I was so close. You gotta be kidding me.
Hey, I did it.
For you,
What is it?
that's excellent.
Yeah.
8a squared plus 4a. You want to see how it works?
The easiest way would be the trapezoid, right?
We did the trapezoid rule.
I did the whole,
I wouldn't do the trapezoid rule, I just do the trapezoid.
I did a
Formula.
square and then a triangle.
I just wrote it as
Sounds
a
really
trapezoid.
tough.
Here's what you gotta do on this, folks. You gotta speak in terms of variables, but you're good at that by now. And here's what it says. Use area and evaluate the integral from a to 3a of 2x plus 2. What kind of a function is that?
The line,
It's linear.
linear, yeah.
For a greater than 0. Why would that be important? So that you know that this is bigger than this. And keeps you in the first quadrant, which is always nice. Right? Okay. So when you go to draw this, because you got to use areas, when you go to draw this, you hit that line. Here's 1, 2, and it's got a slope of 2, so I'm going to go up 1, 2, and over 1 from here. This is your line. And we're going from, let's say, A to, I have no idea what this is, but it's called 3A. And you need to find the area of that trap. Which means you have to remember the formula for the area of a trap. Anybody remember it?
Base 1, base 2 over
By
2
2 times
plus 1.
The average of the bases, I'm going to write it like this if that's okay. Is that okay? Times the height. That stands for height when our height is actually horizontal. Right? Distance between the bases. Okay, so now we need to plug things in because we're supposed to find area. It's 1/2. How long is the big base?
F of 3a.
3a times 2 plus 2. That's what it is.
That's what I was.
Isn't it? This is the function value when the x value is 3a. So you plug it in. You follow that?
6a plus.
You do?
Yes.
So big base is going to be 6a plus 2. Yeah? Okay. Now I'm going to add on to that the little base. What's the little base? 2a plus 2. And what is the height?
3a minus 8.
Yeah, the difference between 3a and a. 3a minus a is 2a. So, you understand where we got all those details? You have to know this. Do you understand how we make this specific situation fit this? Anybody have any question about that? No? Then it becomes a cleanup process. So I'll leave my 1/2 out here. Inside I get 8a plus 4 times 2a. Half of each of these things is 4a plus 2 times 2a. Distributing 2a gives me 8a squared plus 4a. You see that? It's not too bad if you remember this and if you know how to find these values in terms of a. These are function values. This is the difference between the the x's, which are a's. Does that make sense to you?
Yes.
All right, so if you want to practice the second version of that, the answer is, the next one's a circle, and it's pi a squared over 2. Pi halves a squared is what the next one is.
Over 2.
What's the next one?
Pi a squared over 2 is the answer. Pi a squared all over 2. Or you can write pi over 2 a squared. Same thing.
Wait, on which one?
The second, number 3,
Oh, the second number 3.
is pi a squared over 2.
So the,
Just so you can shoot for the right answer. What?
so the radius of a circle. You find the radius of a circle when you have a function by it's just the square root of whatever is.
Yeah, it's the squared constant in the front, is the radius.
Okay.
So A is the radius of this.
Because the function of a circle would. This A is the radius.
Yes, and that's why you're integrating from negative A to A. That way it makes it a complete half circle.
So it's only pi A squared?
Pi A squared over 2 because it's a half.
Oh,
Circle.
it's a semicircle. But if it was plus or minus, it'd be a whole circle.
Yes. It said find the area, yeah, if it had a plus or minus out in front of it, that one. We good on that one?
Yes.
Okay, the next jump is to number 9. Let's continue with the others. Let's start with number 4. You're familiar with that and what you worked on. So number 4, you've got some ones to practice and you're supposed to use Nint to do it. And number 4 says, use Nint means get your calculator out and do this. And it's ugly. But it's enterable. It's a transcendental combined with polynomials combined with, and it's rational, meaning it's fractional. So that means you gotta really pay attention to your principles. And I gave you some to practice. Did you practice
Yes.
yesterday, and did you have any questions? It's on page 282 if you want to go there. Page 282, number, one's like, what was it, 7 through? Yeah, 7 through 22, using it. And I will tell you, I don't see any on here that are as complex as this. Do you want me to make one up, see if we can all enter it?
Yes.
Yeah, I'll make one up that's similar to this one, but not exactly like it, and then you see if you can get it, and I will do it too, and we'll see if we can agree. Because I'm making it up, it's gonna be ugly. Okay, so, like this. Integrate from 1.8 to 4.1, this function. Tangent x to the third plus the natural log of x squared, just for fun, over 2x to the fourth.
Does anyone know if we're recording?
It's pretty ugly. It's like this in here. If you can enter that, it's the same thing I do. I gotta try it.
Mr. Sear said you were recording on Friday, so.
Be sure that you are in radian mode. Oh, by the way, folks, this isn't gonna work because tangent's got asymptotes. Let me change it to something with no asymptotes, like
I
sine.
talked to him today, it's not like we're just gonna practice.
Change this to sine, people, because tangent's not gonna work because we run into asymptotes in the integral.
No. Seems to be 2.
And then 50.11009.
What's your bet there?
Is natural log of x squared or is x squared?
Just the x is squared, just the
This
x
is
is
so
squared.
easy. Please.
Oh, I'm stupid, okay. I thought she said x to the 1/3. Oh, it's just.
Such a small number.
Such a key. 3, boom.
Is it large or small?
It's small. It's
How
under
small?
1. It's under 0.7.
0.047.
Oh, wait, let me look at yours.
Gavin got
Mine a
648.
couple hours.
How many want to punch that in? 0.0474.
I did something wrong. Can you go tell me what I did wrong this week? Because I got like 276.
Oh, it did divide.
What?
Oh.
You have to have that in parentheses, otherwise it will only divide by 2 and then multiply the result by x. Put that in parentheses. You have to put this denominator in parentheses, folks, otherwise it'll only divide by 2.
Oh.
And then multiply by x to the 4th, which is not what you
Now
want.
I'm
What did you get?
like a half.
0.04747.
Yeah, I'm still trying to clean up these.
Did you get that?
I might have. It takes a
Four.
minute or two.
What?
Takes a minute or two.
Oh, yeah.
Aha.
You got it first time? Gotta put those denominators in parentheses. Everybody get it? That's the type of thing you're up against on number 4.
What's the answer?
0.04747. Do you want me to take a look and see if I can help you with it? Or?
This one, yours, this one, that's sunspot.
The shiny.
Can I change this to classic also as a normal
I didn't do that, I just looked at sunspot.
You might not like it.
Yeah, in the middle of the screen. It's in the middle of his screen, it's that dark spot. I do
Use
that.
that. Use that.
I just want to check and see.
Oh, hurt you.
That's the problem. It's not sign, it's the sign, one single sign, X key.
I just,
So only the X is so right here, we're going to raise to
finish notes. How are you watching?
That's the
You have to have those, like, third hands, because we don't have 16. Third hands.
This also,
Third leg.
with all the X keys with that.
Dude, I don't think mine will do that. Why not? Sam.
Understand what I'm doing?
Do it.
There we go. Dude, this is like a lot bigger problem.
Mine does. Sam.
Yeah. I think it does. It's just so, dude, it's like you gotta put your first back. Oh, wait, it lifts the button.
Why don't I just do that off?
There you go. I just have one that says at 5:21:12.
Mine has nothing.
Wait, what does it look like when it's up?
Like that.
What, really? People do me. Yeah, check it to see who's taking their names in the calculator.
Say, why don't I just do it off, dude? You gotta write your name on it instead of this. That's where they put it. Like they put it on. It's not on here, and then they put it back on.
Or writing it on 5 days. Well, that'd be too easy. And everyone would know. Jesus, we're doing calculus.
And your lives that remain
Exact
exact
same.
brain.
So
He was lost somewhere in the first trimester. He never came
Still
back.
lost.
You can go back to,
I'm like, you kept.
But I don't want to.
Oh.
I know. Like a week or two ago.
I'll swear you.
I'd give him a gift away. What the hell?
Dude, I was kind of satisfied.
What's that? Come on, dude.
you can start again, practice, that's what you're supposed to do. All right, we ready to look at number 5? Number 5 is one of your favorite kinds where they give you the values of 3 integrals. You know, look at your practice problems. Look at your practice problems. Remind yourself what it's like. Number 5 is on page 290.
These ones are nice. 1 and 2.
290, where they give you the value of 3 integrals to different things, and you got to decide if it meets the rules or not.
You can't divide.
You cannot divide or multiply individuals. Okay? So here's what it's going to give you. It's going to give you Roman numerals 1, 2, and 3 of things that may or may not be true. You choose the ones that are and answer 3 only, 1 and 2, 1 and 3, 2 and 3, or 1, 2 and 3. It's a multiple choice, and those are your 5 answers, 5 options. Do you understand what I'm saying?
Yes.
So of the 3 Roman numerals, figure out which ones are true, and then find the A, B, C, D, or E that has those 2 in it. Everybody clear? What you're gonna do? Make sure you know your properties. Make sure you know what's not listed in the properties. Okay, the next one. All it says is number 6. What?
So, quick question on 5.3, number 1. It has the integral from 1 to 2 of f of x and an integral from 1 to 5 of f of x. And it was asking for, you just subtract it.
It's asking for the integral, I suspect, from
2 to
2 to 5.
5.
Yeah,
Yeah.
that means you take the 1 from 1 to 5 and you subtract the 1 from 1 to 2.
Okay. Just
So it'd be
making sure
10
we do
actually.
that.
It'd actually be 10. Yeah, okay. All right, so number 6. All it says is evaluate. It is a, what do they call it, definite integral, which means it has a lower limit and an upper limit. And the thing that you are integrating, which means anti-derive, is a polynomial. You should have no trouble with this. You should have no trouble, especially since you have a calculator. It doesn't say you can't use a calculator.
So you can use it.
Yes. And if you trust it and you know you put it in right, then you can just write down the answer and get full credit. If you want to show me your work, then you should show me your anti-derivative.
So you have to do f of b.
I would do it both ways and make sure you can answer. What?
F of b minus f of a.
Yeah, capital F.
Yeah, but
Antiderivative at b minus antiderivative at a. Okay. Okay, we ready? Number 7 may seem confusing to you, but it shouldn't be. Listen to number 7 so you know what to expect and how to handle it. Number 7 also says evaluate. And it is a definite integral. But the function is transcendental. So it says evaluate this integral, and then it says using part 2 of the fundamental theorem of calculus. You are not capable yet of taking this integral by hand, which means you're going to do what? This is more of a thing to see if you can put transcendentals in calculus.
Wait.
so you just use mint again?
Yes. But the thing that's confusing about it is it follows it up by saying using part 2 of the fundamental theorem.
Don't want us to do that.
You don't want us to use part 2?
Actually, I lied. You could, well, you are using part 2 every time you use int.
Yeah.
You're using part 2 by finding, it finds the antiderivative, it evaluates it at the top minus the evaluation at the bottom. It's got a program for it. However, this one, sorry, I lied about it. It is a transcendental, but it is the derivative of something. So you could antiderive and show me your work,
Oh, no.
but I don't require it. But if you want to show me your work, you should. Just in case you miss it.
I
You
just
can
don't
show me
think
some
I-
work on what you intended to do, then I can give you credit. Otherwise, use your calculator to give me an answer. Okay? Are you want to go over your transcendental derivatives so that you know what the antiderivatives are?
That's all I'm gonna do for
Number 8. Shh. Number 8. Number 8's answer looks like this, which means you got to produce a graph. Okay? And here's what it says. It has 3 parts. The first part is a graph, and it says graph the function y equals, and it gives it to you, over a certain interval. And the interval is precisely what is the left side and the right side of this graph, so pay attention to it. That's all you do is graph that function. Means you could put it in your calculator and just plot it. Get a few points off your table if you want, plot them carefully and connect it. It's no big deal. B says, and this is the clincher, it says B says, integrate that same function over the interval. Also not hard. Calculator.
So you're just using that load from the calculator.
C part. Shh. C part. Find the area of the region between the graph and the x-axis. Isn't that what you just did in B?
No.
No, it isn't.
Wait, well, absolute value of the function.
It says integrate the function over the interval.
Yeah.
C says find the area of the region between the graph in part A and the x-axis.
Absolute value. That means you gotta do it by hand.
When it says integrate,
Absolute value.
if you absolute value it in the int, you'll be fine.
You get absolute value. Yeah.
You can absolute,
numbers.
you just put absolute value and give you a parenthesis, put the function in there, close it, comma x, comma low, comma high. But it should give you a different answer from the B part if part was below the x-axis when you graphed it, right?
Yeah.
And if that's the case, the integral should be less than the area.
So
You understand what I'm talking about? You understand this vocabulary? This is a vocabulary question. Still use int everywhere, but it's a vocabulary question. You've got to understand what it is they want before you can put in the correct.
Sorry, which one is this?
Number 8. Number 8 are the ones that I gave you to practice at the bottom of the review. Those little, that little chunk of questions at the bottom, that's where you practice those. And please understand the difference between what's asked in B and what's asked in A.
So to integrate the function over the intervals,
Whatever the interval they give you. And then find the area of the region between the graph and the x-axis.
so we plug it in.
Huh?
The absolute value, it
It does.
Worked out.
Plug it in.
So honestly, this is not a math question, folks. This is a vocabulary question. Make sure you understand the difference between what's being asked.
Yes.
Okay? We ready to go on?
Yes.
Number 9. Anybody try number 9 from the page?
Yes.
Did you discover how to handle it? It was pretty weird, huh?
Is this the one that seemed way?
Is this the one like the plus?
No?
Okay. Then I was way off.
Okay, watch this, folks, because this is clever and kind of tricky and really hard to do if you hit it cold on a test. That's why I'm going to give you some. That's why I gave you some practice problems. Shall we do A together and then you can try B?
Yes.
It says, let f of x equal 2x squared minus 1. Okay, so I'm putting that up here for the sake of the viewers. It says, find k so that the integral from 0 to x of f of t, this is t up here, we're using a dummy variable because the integral itself is a function of x, plus some k value equals the integral from 3 to x of f of t dt. We have to find k. Any ideas?
F of B minus F of A, something like that equals 0.
Does,
Can you solve for k right now?
yes.
Yeah, you can. May not know what the number is yet. You could solve for k. K is going to be this integral minus this integral. Right? That's just a simple algebra move.
Yes.
Just kick that over and subtract. That's what k is. But now you gotta say, well, I still, sorry, this is an x. Sorry about that. Sorry.
Okay.
Sorry. Okay, so now how can we deal with this in order to find a value for k? Because this is a number. We gotta find the number for k.
Make it negative and then go from 0 to 3.
Isn't it just the integral from 0 to 3 of that?
Is it?
Yeah.
Or do you have to do an adjustment of a sign someplace?
No, it's the same, isn't it?
You have to do an
From
adjustment.
3 to x is the same, from 3 to x minus 0 to x is the same as 0 to 3.
You need to, the second one.
Without any adjustment of signs anywhere?
Yeah.
No.
You need to adjust.
Are you
If
sure
you
When
just,
flip
you
it.
flip the.
You go from 3 to x, you wanna start down here with x on this one, right?
Oh, yeah, it's gonna be a negative. It's gonna be a
X.
negative.
To 3, when you do that, you gotta change this.
Wait, why did you just do like? Nah, when I was. That's a 0, that's a 0.
Top of zero.
Tops a 0.
Oh, thank you.
Okay, I was
What I get for talking. Sorry, I was looking over here, sorry.
So now it would be negative integral from 0 to 3.
Yes, or you can integrate from 3 to 0 and just take the sign it gives you, whatever you want.
Oh, that's true.
But you can go, this goes from 3 to x, and in the turning over here, it goes from x to 0, which means that's the same as the integral from 3 to 0 without any adjustment of sign. If you don't like this, if this bothers you, and you want to go from 0 to 3, then just account for it with a negative or
When
negative.
you go backwards, it always negative, right?
Yeah.
Okay.
Yeah, it'll turn out with the correct sign if you do this. It'll also turn out with the correct sign if you do this.
Okay.
It doesn't matter to me which
Plug
one you
that in
do.
your calculator, either way.
You can do this, or you can do this, since Connor came up to look here.
And we are just supposed to mint it.
Or you could anti-drive, I don't care.
If you sat where normal people sat.
But it's this integral that I expect to see on your work. After that, I don't care how you handle it. You should get negative 15.
And then,
Why does this work?
Because of those rules of integration that say that if you go from, this is what it was before. We took this integral over here and subtracted.
right,
And it was 0 to x.
and then,
And that gave us nothing to integrate because we still got x's at the top.
Yep.
But the rule, it says that if you integrate from 3 to x and then start this one down here at x and go to 0, start this one where this one ended up, you end up with this one.
right, okay.
But to make that happen, you have to change the limits of integration and change the sign on your integral.
End and start on the same point.
You see?
Yeah.
So when it comes to it, this right here whittles down to this. And if you don't like integrating from something larger to something smaller, you can go from 0 to 3 but change your sign again. That's what I'm saying. And this has a value, and it is the value of k.
Okay, that makes sense. Thank you.
Is everybody clear on this? You should be getting negative 15.
So, we'll solve, we'll get to there, it'll be the integral from whatever, f of t dt. We just plug the function in for,
Integrated. Because the t has now turned into an x. Since we don't have an x in the integration limits anymore.
right then.
You see it? Yes.
I think I put it wrong.
And then we integrate to x squared. Integral.
You did, it's just 2x.
That's what?
2x squared minus 1.
So what's the answer to number 15?
Sorry?
What's the answer to the first number
I got negative.
on the other side?
This is supposed to be.
Other side has
Yeah, it's
one
supposed to be
on the
negative.
bottom. It's
Start
the
with
other
start
side's
with-
the bottom.
Oh. I will tell you that in just a minute. We haven't done the B part.
But is it answer negative
Oh.
or is it
It's negative.
We haven't done the B part, people.
Miss,
I'm doing the B part of number 9 I'm doing the second number 9, sorry, it's on the top of the second page. That's how you do the A part to find K. To do the
is
B
the
part,
answer to A part 15 or negative 15?
negative 15.
Oh, okay.
Okay, now listen, shh. The B part, the only thing A and B have in common is that they're using the same function. One is not dependent upon the other at all, except that it's the same function, 2x squared minus 1. So what they want you to do now is find the derivative of the integral from 0 to negative x of that same f of x, 2x squared minus 1. What would it be? 2x squared minus 1 with a negative run through it because they're changing it.
Dang it.
So it'd be negative 2x squared plus 1.
What's for the final
For the first 9b?
second one? You see, you're taking the derivative of an integral, so you just drop the function in
I was
where
looking
x
at the
is,
first one.
do the
that's
work
why.
out, and then multiply by its derivative.
Multiply by its.
All right, here's B.
I was looking at 9, the first 9b.
Here's the B part. It says, find the derivative of the integral from 0 to negative x of the same function that we were dealing with in the first part. Which means this, find the derivative of the integral from 0 to x of 2x squared minus 1 t squared minus 1 dt. That's what that means. Are you with me so far?
Yeah.
Now, sorry. The derivative of an integral is just a function. Evaluate it here. Times this one's derivative. So it is literally this, 2 times negative x squared minus 1 times negative 1. Because that's this thing's derivative.
And we just, you have to actually plug it in. The negative x.
Yes, and this will be an expression, but the expression is, this is just going to be 2x squared minus 1. It's got a negative, so it's going to be negative 2x
So
squared.
it'd be like 2x, if there's 2x up on top, it'd be 4x squared minus 1.
What?
Like if there's 2x on the top,
Instead of negative x,
if there's 2x on the top, okay, it'd be like 4x.
Then it would be this, where the 2x would be 4x squared minus 1 times 2.
Which is then
8x squared minus
8x squared.
Minus 4.
two.
2.
Plus
4.
Plus
2. All right, so the answer to the 9A and B on the previous page, which is the one I was supposed to demonstrate, the answer for A is K equals negative 12.5. The answer to B is 12x plus 8.
What was A again?
A was K equals negative 12.5. B is 12x plus 8. We okay on number 9? Okay. Number 10. We got 2 values of this one too. I mean, two problems to work out with different graphs. And what you'll be given is a picture of a graph just like this. And you will be asked these 5 questions. So looking at the first number 10, and knowing that S of, which is the subject of this, most of all of this, S of t is the integral from 3 to t of f of x dx, and you're looking at f. So, what is the particle's position when t is 3?
You have to integrate it as the function.
you have to let t be 3 in the integral because s is position. It's saying, what is the particle's position? Which is what that function is. It's an integral function. When t is 3.
Wouldn't that be 0?
Yeah. Because the integral from 3 to 3 is 0. I don't care what the function is, the integral from 3 to 3 is 0.
Wait, so when it always asks the particle position, it's always just at a specific. No, okay.
It's always evaluating the position function, which is an integral.
Okay, I got messed up because it was at 3, so it's just.
So
Yeah.
Do you all understand why it must be 0?
Yes.
B part. What is the particle's velocity at t equals 5?
3 or 2 or 2 and a half.
2 or 2.5? Yep. Because you're looking at a velocity curve.
Okay, that's.
That's the function. F of x must be velocity. Do you know why?
Because it can't have a negative position.
Because the derivative
Integral is position.
of position is velocity, and the derivative of an integral is the function. That's why you're looking at f of x. You with me or not?
Yes.
I know why we're looking at f(x), but not the way you.
Okay. Up in the words of the problem, it said s, which is position. Position is an integral.
Oh, okay.
Since velocity is the derivative of position, velocity is the derivative of that integral, which is f. So you're looking at f,
So this f, this right here is
a velocity
the
curve.
velocity curve, and then it said the position is equal to the integral from 3 to t of this curve.
Yes.
Okay.
Okay. So, do you understand then how we found the velocity to be 2 or something near it?
Yes.
Because you're looking at the velocity function. So when x is 5, what is y?
Oh,
Because you're looking at velocity. Do you understand you're looking at velocity? C, approximately when is the particle's acceleration 0? When is a time question?
7.
That's 7. Because isn't acceleration the derivative of this function you're looking at?
Yes.
And when is the derivative 0?
7.
Only one place. That's 7. Because that's where it has a horizontal tangent. Is everybody clear on that or not?
Yes.
Okay. D part. What is the particle's position when t is 6?
It'd be 0 again, wouldn't it?
No, because it's 3 to 6 this time.
Oh yeah, you're right. We'd have to integrate this one, wouldn't we?
It's like a perfect
I'm going to use geometry. That's the reason why I made that portion of it very straight.
Oh, thank you.
So is it give me straight on the test?
If they ask you a question like this, absolutely.
Okay. So
6
1
by
half
3
of 3 or f of 3, so
is 9.
It's 9. It's the area of a triangle whose base is 3, whose height is 6.
Oh, 6.
3 times 6 is 18. Cut down.
I saw it.
No, I read that height is 7.
It's just a triangle.
I mean, trapezoid does. Where does the height
Height
of
is
6 come
7.
from?
I don't know.
It's pretty clear over there. I think it's 6. But it'll be very clear on the test.
Okay, good.
And if it's not clear, they'll tell you what the point is so that you can see how it is. Do you all understand why the answer to number D, part D, is 9?
Yes.
Do you all understand why I had to make that portion of the graph straight?
Yes.
E, when is the particle's position the smallest?
What's that?
10, 0. When is the position the smallest?
No. Yes, when is its position the smallest? You'd think it would be at 8.
No, it's at 0.
It is at 0.
But
And the reason why is because when you integrate from 3 to 0, you get a negative. You got to remember, it's only from 3 is your start point. So if you go backwards, you're going to get a negative value for that biggest chunk of the graph. That's your biggest negative number. Or in other words, your smallest number. Does that make any sense to you? All right. Okay. All right. It has to do with the definition thing, of course, eventually it goes from 3 to 2. It starts here. If you integrate from 3 back this direction, this is that is a bigger negative number that added this positive stuff to this big negative. This is a negative.
Please stop, please stop. You please stop.
What?
I was thinking, yeah, absolutely.
All right, so it has its greatest negative value, or it has its smallest value when t is 0, because that's when you get the greatest negative number, the most left negative number for a result, because of the size of things. So you guys can try number 10 on your own. I gotta hurry if I'm gonna make it. We have 11 and 12 to do. These are easy though.
No.
11 and 12 are on your review. Did anybody try those? 11 says, use the trapezoid rule with n equals 4 to approximate the value. And it's an integral. And if you know how to use nint when you're looking at an integral, not nint, but Riemann. If you know how to use that when you're looking at an integral, it should be easy.
Yeah.
Or you can apply the trap rule. There's only 4 partitions, numbers to add up. Do you know how to use one of those 2 rules, or do you have any idea what I'm talking about? Do you know how to use Riemann on this problem? It'll be presented to you as an integral like this. It will say, use the trapezoid rule with n to approximate the value of, it'll say something like this. 0 to 8 of 2x squared minus 6x plus 1. Do you know how to use Riemann and the trap portion of it to evaluate that?
You put that in the y, right?
Put that in f of x.
And then you hit program Riemann.
Yes.
And then fill in your points. 0 would be your leftmost endpoint. 8 would be rightmost endpoint. And then you just do however many partitions.
Yeah, how many partitions it tells you to do in the problem for n. Hit enter and it'll tell you. It'll draw for you and tell you.
Why did you put that one in, not the
How many partitions?
Because you're asking for trapezoids to approximate the area, which is what the integral indicates, under that curve.
Yeah, and then you gotta do the trapezoid.
What?
You can't just do anything. You gotta hit trapezoid.
Yeah, you have to hit the trapezoid portion.
So just like the 2x
Use your calculator.
plus 1, right? It's not the integral per se.
That's what the integral's asking you to do, and it's with underneath that function. Use trapezoids to approximate the integral, not the area, the integral.
Okay.
Understand?
If it's that area, you have to absolute value.
Yes.
And then.
Yes. Then this says just to approximate the value of the integral. It does not say area. It says area anyway. So pay attention to what's going on. Okay. We okay on number 11? You understand how to use your Riemann to do it?
Yes.
Number 12, last one on the test, says use Simpson's rule to estimate the area of this metal. It gives you a strange looking little metal with partitions on it. Do you know how to do that?
Go and run through one of those. Jeez. Just let's try.
Here's the metal. I'm going to partition it like this. And it'll show you a picture like this on here, and it will give you a bunch of numbers. Pretend these are all the same width. I'm just pretend, okay? Okay, and right down here, these are supposed to be kind of flat at the end. So let's say that this right here, this distance right here, from here over to here, let's say pretend it was flat on the edge of the. Now let's say it was 110. This is 120. This is 121. This is 115. This is 90. Okay, this is 82. This is 80. This is 79. And this is pretend flat from here to here is 60. Okay, do something like that. And it says use Simpsons to approximate the area of this metal. Okay, there we go. So how do we do it? Oh, by the way, it'll tell you. Does it tell you in the words? I think it tells you in the words. These are 50-foot intervals. Each one of these. So how do we use Simpsons to approximate this? What would you write?
50 over 3.
50 over 3 times 60
plus 4 times 79 plus 2 times 80 plus 4 times 82 plus plus 2.
In a minute.
So 5 times 115 plus 2. Plus 421 plus 110.
And the trapezoid is h over 2.
Yes.
So you're good to go.
Yeah, I never taught that.
And
Okay,
then put that
have your
in.
calculator.
Sheree, carry.
If you can write that, that'll get you half the problem. You can calculate it right, get the other half, so be careful when you type it.
What do you think about that?
And will be even too, don't need to worry about that.
What are you guys thinking?
They wouldn't ask if you use Simpsons on lots of partitions, lots of partitions. Okay,
Classes basically.
so that's the test, I'd like you to take it Monday. If you got any questions, you have my number, call me over the weekend.
I
if
was
you need
very
to.
scared that we were gonna take it.
I know, I was like, that's it.
Because of Wednesday, everything got set back.
Oh, that's the call. Thank you so much.
I didn't do that on Wednesday.
Oh, you're
I'm going to take this over here and show you this.
That'll be fine.
Sorry, probably getting dizzy. This is the sample of Simpson's rule, and I use this board because I didn't want to erase anything. Gotta back up a little bit. I don't know if you can see that, but I hope so. Okay, end of lecture. See you later.